Okay, in this last bit we need to look at the other two forms that are possible for the half-angle formulas for tangent. I've gone ahead and copied down the half-angle formula that we've already derived for the tangent of 1/2 u, and we're going to use that formula to develop the other two types that exist. The way that we're going to do that is by using the conjugate. In one case, we're going to be looking at the conjugate of the denominator. That's what we'll start with, and then we'll look at the conjugate of the numerator and see how the results are similar and how they're different. So with that in mind, we're going to start with this first formula. And in that case, we're going to leave everything the way it is for the moment. But inside that square root, we're going to do a little multiplying. So we'll start by just copying down what we have. And I want to multiply that quantity, that fraction that we have inside the square root. I want to multiply both the numerator and the denominator by the conjugate of the denominator. So in this case, the conjugate of 1 plus u would be the 1 minus u, which means here I want to multiply by 1 minus cosine u in both the numerator and the denominator. Keep in mind that that's still happening inside our square root, and ultimately all we've done is multiplied by 1, so we haven't changed the value at all. But look at what's actually developed. In the numerator, we now have the quantity 1 minus cosine u times itself, which means we could rewrite that expression inside that numerator as 1 minus cosine u quantity squared. Now, in the denominator, what we've created is a difference of two squares. The quantity 1 plus cosine u times the quantity 1 minus cosine u could be rewritten as the quantity 1 minus cosine squared u. Now you should recognize that that quantity 1 minus cosine squared u that we have in the denominator is actually a form of one of the Pythagorean identities. Specifically, we should recognize that 1 minus cosine squared u is equal to sine squared of u. So we're going to do that substitution in this next step. In which case we've got a quantity 1 minus cosine u squared in the numerator. And now our denominator is a different quantity, sine u squared, in the denominator. So what we've done is we've created the same type of situation in the numerator and denominator in that we are now taking the square root of a quantity squared. And we know from previous experience that when that happens, that squared and the square root are going to cancel each other out, which in this case means that that square root is going to go away and that we're going to take away these two squared quantities in both the numerator and denominator. So what we'll be left with in this case, in the numerator is 1 minus cosine u, and in our denominator a sine u. Now you'll notice that I've left off the plus or minus, and here's why. In the numerator specifically, we know that the cosine of u, that any cosine expression has a value between -1 and +1 inclusive. Meaning it could equal -1, it could equal +1, or anything in between. If we consider a number between -1 and 0, those negative output values, when we substitute those in here in place of the cosine of u, 1 minus that negative value, we know that minus a negative becomes a plus, so 1 plus that value means the numerator is going to have a positive output no matter what value of u we use, because of the way that cosine u behaves. Likewise, if we use between 0 and 1, and we can include 0 in either of that, 0 to 1, those positive values, when we take 1 minus a number between 0 and 1, we get a result that's either 0 or a number that's positive between 0 and 1. So there again, that numerator is still positive. So in this case, our numerator of this expression is always a positive output. Now let's consider that denominator. The denominator sine of u, like the cosine of u, has a value between -1 and +1 inclusive. The thing that's nice about tangent and sine is that no matter which value of u we use, whatever quadrant we're in, sine and tangent have the same positive or negative symbol attached to them. They're either both positive or they're both negative. And you can check that by looking around your values in the unit circle to see that that's going to be the case. So in this case, whatever positive or negative sign the sine of u has, then the tangent would have the same symbol attached to it. So we no longer need this plus or minus. And remember that plus or minus before was carried over from the sine of 1/2 u and the cosine of 1/2 u, and in that case they were just visual reminders. Check to see if your answer should be positive or negative. In this case, it's taken care of with this sine of u. Since we're going to have a positive number in the numerator, if the sine of u is positive, then the fraction overall is going to be positive. If the sine of u is negative, that positive divided by the negative means that the tangent will also be negative. So the symbol in this case, positive or negative, is taken care of by this sine of u, which means we no longer need the plus or minus. So this forms one of the three ways then to express a tangent half angle. So the first one is what we have up there at the top of the screen, what we proved in the previous video, and now we have our second of the three. And its particular second one was formed by multiplying the numerator and denominator by the conjugate of the denominator. Now, I mentioned earlier that you could also multiply by the conjugate of the numerator, and that's what we're going to look at next. So we're going to start with this same expression, but now instead of multiplying by 1 minus cosine u in both the numerator and denominator, we want to multiply by the conjugate of the numerator, which is that 1 plus cosine u in both the numerator and denominator. So our third option then becomes the tangent of the quantity 1/2 u is equal to positive or negative square root of, and we're going to start with that same expression that we had for the tangent of half u from the previous video, and we're multiplying by the conjugate of the numerator. So in this case, we'd have 1 minus cosine u over 1 plus cosine u, and that's the value that we proved in the previous video, and we're multiplying that whole quantity by the conjugate of the numerator, which in this case is that 1 plus cosine u. My pen is missing, so we'll just do it in the same color. Okay, so we're going to use 1 plus cosine u over 1 plus cosine u. Now, similarly to what we saw in the last little bit, what's going to happen here is that now we have a difference of two squares in the numerator. So our numerator now becomes 1 minus cosine squared u, and our denominator is that quantity 1 plus cosine u squared. Keep in mind all of that is contained in your square root symbol. Now, we mentioned before that the 1 minus cosine squared u is one of our variations of a Pythagorean identity. We're doing the same thing in this case. So we know this quantity now in the numerator gets replaced with a sine squared of u. Denominator is going to stay that quantity squared. And there again, just like what we had in the last part, we have now a square root of a squared quantity over a squared quantity. So there again, we're going to simplify both of those by canceling the exponent of 2 with that square root. So what we'll end up with here in the numerator is the sine of u, and in our denominator, 1 plus cosine u. And there again, we don't need the plus or minus that's attached to it in the previous step because of the same reasoning that we had before. That 1 plus cosine u is always going to be positive. The sine of u will be dependent upon which quadrant the u value is in, and the tangent will take on the same symbol, positive or negative, that sine has. And that forms the third form of the half angle formulas for tangent. So in this case, we have these two that we've just recently proven, and we have the one here at the top of the page. That's the one we proved in the last video. Each of these can be used in place of the tangent of 1/2 u. It's dependent upon what it is that you know. In this case, we only have to know the cosine of u, whatever u is, in order to find the tangent of u, or 1/2 u. Here, in these other two forms, you'd have to know the cosine of the angle u as well as the sine of the angle u in order to find the tangent of the half angle. Either form, though, is acceptable, and sometimes one will be more useful than the other, dependent upon what you're given. So that completes all of the identities that we have in Chapter 5. We've now gone through the quotient identities, the odd-even identities, cofunction identities. We talked about reciprocal identities. We've looked at Pythagorean. We've looked at sum and difference, double angles, power reducing, and half angles. Multitude of things that we have to know. But each of those contribute in some way to our ability to be able to prove identities or to find sine, cosine, tangent values or their reciprocals for any or a variety of angles in whether they're in degrees or radians. So that concludes our identities for this moment. See you all later.